Hello everyone. Today we're going to talk about systems of equations, and now we're going to look at them in three variables. The previous week we sat there and solved systems of equations in two variables and looked at substitution and elimination. And today we're going to actually spice this up a little bit and look at three variables. And today we're going to look at substitution. When it comes to a system of equations, we know that a system is two or more equations. We're now going to look at this in three variables, so we're just going to say variables x, y, and z. When we were solving systems of equations in two variables, for example x and y, it was a two-dimensional function that we came up with, and we were looking for those intersections. So now that we are actually in three variables, it now spices it up and actually makes these three-dimensional. So when it comes to solving these, we have three different possibilities, just like we did when it came to two variables. You can have one solution, which is where you're taking these three-dimensional planes and they're all going to intersect at one particular point. And that particular point that they intersect at is called an ordered triple. It's the x, y, and z variable, or whatever those three variables are of your equations is your ordered triple. This is what we're going to focus on for our week lesson. It's the first time looking at systems of equations with three variables, so I made sure that on all of the problems you should be able to come up with one solution. Other possibilities that you can come up with are if you take your three variable and you graph them, the three planes intersect on a line. Technically, we're looking for that point of intersection, and so a line is made up of a whole bunch of points, so infinitely many points technically, because even on these planes, even though this is a representation of just a piece of that plane technically goes on forever. So no different than that line. That line is a continuous line. A line is made up of a bunch of points, so it'd be infinitely many solutions because there's infinitely many points on the line. And then the third option would be is to come up with something that's a no solution. So ultimately, no solution is just when it takes these, for example, these three equations and they graph them in that three-dimensional plane. They're not intersecting at any point in common. Example like on this one, granted the green and the purple intersect that yellow plane, but they don't have one in which all three of them are in common. On here you have three planes, but these are three parallel planes, and of course they're not going to intersect. We're still going to focus on, when it comes to solving these systems, no different than in two variables, we're going to look at substitution and we're going to look at elimination. And for our purpose for this video, I'm going to focus on substitution. I'll do another video looking at elimination. So let's just jump into doing a problem. So they want us to solve the system of equation, and they want us to use substitution. So when I look at this problem, I have three equations, and I have three variables. Variables x, y, and z. When I get done with this problem and I know that I have my solution, I should have an ordered triple. I should be able to solve for x, y, and z. So to start this problem, my goal is to get to two variables and two equations. If I can take what I have within this system and get down to two variables and two equations, I'm right back to where I was on last week's assignment. So by looking at this one, the nice thing is x is already solved. So I'm going to see if I can use it to my advantage. If I take what x equals and I plug it into my first equation, it's ultimately going to reduce that equation into terms of y's and z's. And if I put this into my third equation for my x, again, I end up with y's and z's. So that's my goal, those two variables. So let's work on that. So let's start off with that very top equation and substitute in our x. So we would have what, 5, and then for x we would then put in negative y plus 2 minus 2z equals negative 26. Using our distributive property, we have negative 5y plus 10 minus 2z equals negative 26. And then I just want to go through and simplify my equations as much as possible to keep it in the simplest form as possible. So I'm actually going to subtract 10 on both sides. So I'm going to end up with a negative 5y minus 2z equals negative 36. Now I'm going to do the same thing looking at that third equation and substituting in x. So there I have negative 4, and then my x is negative y plus 2, finishing out the rest of the equation, plus 2y minus 2z equals 22. Using my distributive property, I'm going to end up with 4y minus 8 plus 2y minus 2z equals 22. Again, I'm just going to simplify by combining like terms and getting this in the simplest form as I know. So if I combine my y's, I'm going to get 6y, I have 2z, and then I am just going to add 8 to both sides, which is going to give me 30. Now I have two equations in two variables. This is what we had last week when we were looking at systems of equations. So I'm going to look at these two equations. I'm just going to rewrite these. So I have negative 5y minus 2z equals negative 36, and 6y minus 2z equals 30. Now when I look at these two equations in two variables, I can solve these. Granted, I can either make the choice of using elimination or substitution. It's a personal choice on your end on which way to do. Since on this video I was focused on using substitution, I'm going to continue with substitution. But if you don't want to use substitution and you want to use elimination, by all means you can do that. So I'm going to look at this second equation and I'm going to solve it in terms of z. So I'm going to subtract 6y from both sides, which is going to give me negative 2z equals negative 6y plus 30. Divide both sides by negative 2. So now I have z equals 3y minus 15. So now I know what my z equals. I can take that and substitute it into that first equation. So then I would now have negative 5y minus 2, and instead of z, I'm going to write what z equals, 3y minus 15 equals negative 36. So negative 5y minus 6y plus 30, by using my distributive property, equals negative 36. Combining like terms, I would have 11y's. I know that I'm going to solve this for y, so I'm just going to go ahead and subtract my 30 from both sides. So that's going to give me negative 11y equals negative 66. Divide by negative 11, and I know that my y is going to equal 6. So I can actually now go back to my ordered pair, my x, y, and z, and I just found out that my y was 6. So I still need to find out what x and y, or x and z are, pardon me. So if I go back here, I know that my y was 6, so then ultimately I can just pick one of these two equations to plug my y into, and I can solve it for z. Personal choice by all means, and just for simplicity's sakes, I'm just going to pick the second one. So 6y minus 2z equals 30. I know that my y is 6, so y times 6 minus 2z equals 30. 36 minus 2z equals 30. Subtract 36 from both sides. Negative 2z equals negative 6. Divide by negative 2. Z is going to equal a positive 3. So now I know what my z value is, so I can go into my ordered triple, and I can put in that my z was 3. So now I just need to find my x value. I can actually just stay right on this page, and I can look at those original 3 equations that they gave us, and I can pick whichever one I want to put it into, because all I need to do is find out what x is. So I'm going to look at that second equation because it's x equals. So I think that's going to be my quickest and easiest bet. So we had x equals negative y plus 2. We know that x equals negative. We know that our y is 6 plus 2. So we get x equals negative 4. So then I need to plug that into my ordered triple as negative 4. Now I have my ordered triple, and that is my solution. So my solution is negative 4, 6, 3. These problems do take a little bit of time, and they take a little bit of paper to get through, but I have faith in you guys. Reach out for help. We have the Zoom meetings, you have my email, you have my my Remind. If you have questions, make sure you reach out. I'll talk to you soon. Bye.